In part one of the demo, we're just going to show that when you run the clients and servers, you see the correct functionality, which is increment being called with +1, +2, +3 in both client, and then finally you get value at the end. So as we run both our clients, we should see them start to call increment. And we can see in the custom server now increment being called, and now in the custom client, the value being returned. So we can see for client, for server launcher 1, get value returned to 12. And we can see an increment being called, and then a get value earlier having returned 9. And as I'm highlighting, you can see each of the increments being called, and they're each using a different method. So one was RPC, one was remote procedure, or remote procedure call was RPC, another was remote assignment. So in this part, we're going to show that how our receive call works. So I've set a breakpoint in receive, and as you can see here, we're about to call receive. So if we resume, or rather now, we're receiving calls from the client because the clients were not blocked. So as we can see in the client, we're about to call increment. And if we switch to our server, where we're about to call receive, and we continue, we'll see that the receive receives the earlier not RPC call. When we resume the client, we'll see that we see here that we have received a message. And now finally when we call system.out.getValue, we'll see that our receive returns, the server executes receive and returns a value of 12. And finally when we run the same thing over here, we should see the same value of 12. So in part one of the demo, I'm going to show that my factors that I've made implement the correct functionality for the simulation. So as you can see here, we're about to call receive for the next client in our server. And if we progress forward, we go into receive and we stop on right before we get a message. So if we run, we see that that pauses there. And now if you head to the client, we see that we're about to send a byte buffer. And if we click resume, we see that byte buffer is send. And we see that sent is called in the client. If we cut to the server launcher, we see that increment is being called locally or remotely. Now if we go to the second client, we can see that increment has also been called here. If we resume the next client, we see that it says increment called locally or remotely. Head back to the client, we see that it is making an RPC call. When we look at the server, we see that increment has been called remotely or locally there. Again, we continue, and we see that we're about to call get value, and we see it there again, increment was called. So if we resume here, we should see on the server that get value was called. So we see the return value there with a value of 9, and if we switch over to the server, we see right there that a get value was called. And then finally, if we resume the last one with our send object increment of 3, we should see in the server that an RPC call was executed for increasing by 2 rather. And finally, we're executing an RPC call for incrementing by 1. So now when we call get value, we should see that the value is 12. Yep. And that is the required functionality for part 3. And for the final part, I didn't record, or I wasn't able to get Gipsy to work with the simulation because there was an error in the setup and the connection wasn't able to be, or commands rather weren't sent and communicated using my Gipsy implementation. So, but I hypothesized that if I were able to get it work, that it would probably run slower because the way I implemented it was using a listener and multiple bounded buffers for each client connection to a server. So each client would have its own message queue, And I think that if that would probably lead to a slower functionality since you're dealing with several bounded buffer queues, like one for each client, rather than a single bounded buffer that may, in some way, store multiple messages. So it's probably not the most optimal way, but it helps to ensure um, the proper function that we wanted.